Here's a video to help you in graphing reflections of the x and y axis of both the exponential and logarithmic functions. So in all of these, really what you want to do is, number one, list your transformations in order, reading it from left to right, and then do the transformations in that order, and that will really help you out. And so that's what I'm going to do with each of these cases, and so that way you can kind of get a better feel for it, and just knowing like the differences of how they look like and things like that. So we want to sketch the graphs of each of these exponential functions. We're going to label the asymptote in 3 clear points, and then identify the domain and range and interval notation. So as I'm reading it from left to right, the negative in front tells me it's a reflection in the x-axis. Positive 3 with the x means this moves left 3, and this is up 4. So let me list that. So reflection in the x-axis, and then left 3, up 4. Now when we graph this, we want to know, we want to be able to graph our 2 to the x first, right? And then we're going to do these transformations to graph. And so I always pick like 3 good points, or maybe even 4, just depends on, the number that it is. But I pick 0, -1, 1, and for this one I could pick 2. So if I plug in each of these values, 2 to the 0 is 1, 2 to the 1 is 2, 2 to the 2 is 4, 2 to the -1 is a half. Okay, so then I graph that. So I'm going to show that in purple with purple dots. So 2 to the x will look like this, and then like that, right? So that's my main one. And then the asymptote is located here on the y equals 0 on the x-axis. So next, let's apply the transformations in order. So we have reflection in the x-axis. So our x-axis is here. So that means when it reflects, we're actually going to move this point to the opposite side, right? It's the same distance, but the opposite side of that y-axis. So I'm going to do that with pink so you can kind of see that. So it reflects that main point, 0, 1, reflects down here. So it's now at 0, -1. And then the next point is down here. Oops, a little too far. Right here at 1, -2. The next one is 2 at -4. -1, we're at -1. So if you do that reflection first, that's really going to help you out. Next, we're going to move it left 3 and up 4. So that's why I have it both in green. So I'm going to do both of it at the same time. So I'm going to take each of these pink points and move it left 3 and up 4. So let me do that. So this main point, left 1, 2, 3, up 1, 2, 3, 4. So I'm at -3, 3, -3, 3. And then I'm going to move every single point, or you can copy it, right? It's up to you, but you can either copy it, like I know that, from here it's going to go right 1, down 1, and then right 1, down 2 to kind of get to those points, or you just move in each and every point if that is what makes you, that helps you see it better. So left 3, up 4, and then notice it goes there. So we're just copying the graph. Here, here, and then here. Now the other thing we need to move is the asymptote. So we're going to move this yellow here. This is going to move up 4 spaces. 1, 2, 3, 4. So now we have our horizontal asymptote. It's never going to cross it. Is at y equals +4. And then we can finish labeling these points. So I did label -3, 3. I also have -2, +2. I have -4 and 1, 2, 3 and a half. And then I also have it at -1, 0, right? So labeling at least 3. And then we can talk about our domain. So domain is -infinity to infinity. Our range is from -infinity to that 4 where that asymptote is. So now let's graph one where it's a reflection in the y-axis. So we have this one here. So we have 3 raised to the -x - 2. And then so we know that this value up here tells us a reflection in the y-axis. So let me write that. So reflection in the y-axis. And then, so this, what I like to do is think about what makes this 0, right? How is this going to be 0? If I plug in a -2, it's -2, which will be a positive and it makes it 0. You could think of it that way, or sometimes I just like to factor out the negative, so I have x plus 2, right? And it's still the same, right? It's still left 2, because that's what's going to make it 0 in the inside. So left 2 units is negative 3 means down 3. So first we'll graph our 3 to the x. Again, you can just pick points in order to get that parent function. Oh, it should be 1, so that's 3, and negative 1 is a third. We could have it up 1, 9, right? If you plugged in 2, that would be 9 as well. Okay, 3 squared is 9. So first, I'm going to reflect it in the y-axis. So in this case, we're reflecting over this line. So notice now that this point doesn't move, right? It's the same spot. So that stays the same, but everything else moves across on the opposite side. Okay, so you just move it, right? So we did the reflection in the y-axis. Now we're going to move every single point, left 2, down 3. So I'm going to take this point here, left 1, 2, down 1, 2, 3, and that gives me my point there at negative 2, negative 2, and then next left 2, down 1, 2, 3, here, and then left 2, down 1, 2, 3, and then here. Okay, and then so we're seeing that this is now the graph of 3 to the negative x minus 2 minus 3. So again, I need to move my horizontal asymptote is y equals negative 3. The domain is negative infinity to infinity. It's the same. The range is going to be from the negative 3 to positive infinity. And then again, you should label these points here. So I have negative 3, 0. I have negative 4, positive 5. And then I have negative 1. And that is 1, 2, negative 2 and 2/3. Okay, to kind of help you out. Now what I want you to do is you can try these exponentials, so I'll focus on the exponentials in this one. So graph these two. So pause the video, see if you can do it on your own, and then I'll show you the answer when you return. All right. So if you paused it and you tried it out, and so this is the answer. Those are the labels of each of the points. So I hope this kind of helps you out a little bit more with graphing exponentials with the different types of reflections across the x and the y.